For those of you that are just joining us, we're just giving it a couple of minutes till we've got till just gone the hour, and then we will start the presentation. Yeah, I can see a few more people joining us, so just to let everyone know that is joining. We'll be starting shortly. We're just going to give it till the hour before we start. Just give as many people as possible the chance to log on. Thank you. Again, we've got a few more just joined, so just to let you know, we're just going to give it another minute, and then we will start the webinar, and we'll run through the process of how it's going to take shape over the next half an hour, 45 minutes. Thank you. Okay, so I think we've got a few people on, and we're just a minute past the hour, so I think we will kick things off. So firstly, welcome to Wejo Sample Preview. I'm Matthew McCann, the AVP of Enterprise Partnerships here at Wejo. We've got a really exciting webinar to talk you through today about one of the new tools that's come on board that we're really excited to launch. Joining me, I've got Matt Blackwell, our solutions engineer here at Wejo, who's going to talk us through the sample preview tool shortly. And we also have a recorded message from Ollie Ullman, who unfortunately couldn't be here in person, but has managed to help us out with a recorded section about DataBricks as a tool. So just for the benefit, we are recording the session, so that will be available for those that couldn't make it. We will be making that available afterwards. So if we could just move on. Yeah, here we are. So let me just quickly talk you through the agenda that's going to take place. So I'm going to do a quick introduction to Wejo. Most of you are fully aware of Wejo and some of the stuff that we do, so I won't dwell too long on that. I'm then going to hand over to Ollie, who's recorded a short 5-minute introduction to DataBricks as a tool for us. And then really we'll move over to the star of the show, which is Matt Blackwell, and he's going to give us a live demonstration of the sample preview tool. And hopefully we're going to leave a bit of time at the end there to just cover off any questions and a bit of customer testimonials and summary from Matt. But let's keep it an interactive session. So if you've got questions, please pop them in the chat as we go, and I will endeavour to answer them as we go. If we don't answer all the questions, we will cover them off with a follow-up email to do so. But let me just give you a quick brief rundown of Wejo. As many of you will know, Wejo stands for We Journey. Wejo partners with automotive manufacturers to organise and enhance streams of authentic connected car data, and we unlock the value for drivers, public and private sector organisations. We specialise in vehicle data process, billions of data points from thousands of sensors globally. We analyse this data and make it accessible to create customers and economic value, enable safer driving, make cities more livable, deliver a better driving experience. Our key USP is that we work with major OEMs around the world to help them monetize this data, and make this huge data set available to businesses like those of you on the presentation here today. And using this data, you can make better decisions and validate the work that's being done. The data itself comprises of movement data, which I've often termed in the US particularly as breadcrumb trail. This transmits the vehicle's geolocation every 1 to 3 seconds. This is especially useful if you're looking at origin to destination or plotting congestion on major highways and interstates. We've also got a fairly unique data set in the form of event data. This is an event-based capture rate that occurs when key events happen in a vehicle, such as, I'm sure we've spoken about it before with some of you, harsh braking, rapid acceleration, and some of the newer stuff that we've got coming on board now, autonomous braking. All this is collected directly from the vehicle itself. They are connected vehicles in the true sense of the word. We do not rely on aftermarket devices or apps to gain this data. And because of that, the data is not only richer and more reliable, but more accurate. And that's something I'll speak on to in a little bit. So if you just move on that, Yeah, so some impressive numbers to run through. So these are growing all the time as we onboard new OEMs and we add more sensors to complement our existing data sets. We've currently got 10.7 million active vehicles in the US. We curate 354 billion miles so far. We have a capture rate, as I said there, from the vehicle itself of every 1 to 3 seconds. And to date, we've managed to collate 9.1 trillion data points from just under 44.5 billion journeys. And when we talk about big data, which is one of the reasons why we're talking about the sample tool we've got here, that's something like 50 plus terabytes of data per month. So it truly is big data. If you could just move on, Matt. So one of the things that we often get commented on by our partners is the accuracy of our data. And we just wanted to illustrate for you the difference in connected vehicle data compared to some of the other data sources that are available today. So the 3 additional sources that we've chosen are mobile-based, telematic devices, and roadside sensors. And if we look at each of those in turn, we can see that telematic devices, these are available in abundance, but as I'm sure everyone is aware, they're expensive to manufacture, expensive to maintain, and in some instances, like a UBA tracking device, they can be easily removed or manipulated. We then move on to mobile-based collection, which has been around for a while and gives us great volumes. But as we can see in this slide, there's a very wide range in terms of accuracy against the road network. In addition to this, we have instances of multiple probes traveling down a road clustered together. And this can often, in fact, turn out to be a bus, a taxi, or even bicycles in some cases. This is due to the fact that the cell phone will register a speed and assume that the user is driving. And then finally, we have roadside sensors. These are typically used on major freeways and highways. They only capture a point in time or a point in road data. They also do not have representation of many surrounding tributary roads. And again, it's costly to maintain and costly to install. By contrast, connected vehicle data is accurate down to 3 square meters and is a true free feed from the vehicle itself and comes from no aftermarket device or retrofitted devices, as I've said. And as a final point, we're increasingly seeing more and more companies using data to enhance their overall proposition and being able to contextualize and fill black spots in areas that could not get data before. And in some cases, due to the volume and accuracy of the data, it's replacing some of the data sources altogether. And this is where we come onto our offering. So we offer a range of data if we start on the left here, we have our live feed or near real-time data. This is for our movement data set, which is captured every 1 to 3 seconds and can be supplied out to customers in anything from 35 to 60 seconds from the time it happens in the vehicle to the time it's gone through our regulatory wrappers and out to yourselves. We then, with our event data and our movement data, we're able to provide it in bulk batches. So this is done on a file transfer, and it's done daily, weekly, monthly batches. And we have historic data going back almost 2 years now. So that's a really key point that we've got. Then we move on to some of our newer products where we have intelligence. So we are able to predefine, visualize, customize reports and visualizations for our partners. So this is where those that are struggling to take the data in such a large format as it comes, as we've discussed, this is something that's perfect for them. And then we come on to what we're going to concentrate on today here, which is the Data Lab sample preview. So this is a self-serve access to Wejo for evaluation purposes. And this is what we're going to talk about today. This is what we're going to demonstrate to you. It's a way of taking the big data and making it easier for you to access. We'll just move on there. Brilliant, thank you. So we recognize that the numbers that we've spoken about previously are truly big data. And whilst many companies are able to take this data and put it to use for their live projects and products, we do recognize that carrying out this work for the purpose of a data evaluation exercise comes with complexity, diversity, costs, ROIs, and all of these things attributed to it. And for that reason, we've partnered with DataBricks and we've created our sample preview tool. This will enable you to see our data, evaluate the quality, and understand the applications you could put it to use on. And we're very excited to launch this. And those of you on this webinar now will be amongst the first really to see it in action. So before we have a demonstration of that, I'm going to hand over to Ollie Ullman, who is the Senior Commercial Account Executive with DataBricks. And he's recorded a short presentation for us, which he will take us through now.
Thanks, Matt. Hi, everyone. Thanks very much for joining today, and it's great to get the chance to speak with you. My name's Ollie. I'm an account director here at DataBricks, based out of our London office. I've been with the business for just over 3 years now, and I have the responsibility of looking after Wejo as a customer of DataBricks here in the UK. What I'm going to do over the next 4 to 5 minutes is give you a quick overview of who DataBricks are, before handing back over to Matt to talk in a bit more detail around how we're partnering and helping driving value for Wejo customers. And so a quick overview and intro to who DataBricks are. We're the data and AI company, and we provide a lakehouse platform that allows you to unify all of your data, analytics, and AI workloads in one place. We do that by driving a unified approach to analytics built on open source technology. And this has driven us to have over 5,000 customers globally now since our founding in 2013. And you may well know us for being the original creators of some popular open source projects, such as the likes of Apache Spark, Delta Lake, and MLflow, which we'll touch on in a bit more detail in the next couple of minutes. This is a quick overview of some of the customers that we work with globally. I think it's important to point out here that DataBricks can be used by any customer in any size, whether that be enterprise all the way down to sort of 1 or 2 person startups. And the relevant thing here is that DataBricks is able to help any customer where there is a data problem, a challenge, and there's insight and value to be driven from data, then the DataBricks platform can help you get to that outcome. So what's the problem statement that we're trying to solve? It's undoubted that AI and machine learning can drive a ton of value for any business as long as they have the data. 83% of CEOs say that AI is a strategic priority, and there's already a vast amount of value in terms of dollar or pound value that can be driven by AI next year alone. The problem is that most of these projects never even come to fruition. Most of these projects fail at either the early stage or even at the later stage after a vast amount of money has been injected into them by the leaders of leading businesses. 85% of big data projects fail, and even higher amount of data science projects never even make it into production. And that's the problem that we're really trying to solve here. And this is a visual to show you sort of why people struggle with it, why enterprise struggle with data, and why very few of those AI and data science use cases can move into production. As you can see, we have a number of different use cases and personas here, all the way through from data warehousing, engineering, streaming, and data science and ML. Down the bottom, you can see that one of the biggest problems is that from the beginning, there are siloed stacks, which increases the complexity of many data architectures. You have different data environments, such as warehouses, marts, and databases. People are trying to ingest different types of data, whether that be structured data, semi-structured data, and unstructured data, which we start to see more and more now with the rise of mobile phones, social media, GPS tracking, and real-time devices. And also, it's not just about the databases and the types of data, it's what people are trying to do with that. Are they trying to stream it? Are they trying to upload that in batch? Are they trying to prep that data on the fly? And are they just doing simple BI or SQL? Or are they looking to do advanced deep learning, machine learning, and real-time data science? As you can see, one of the problems is that not only there's that complexity around architecture, but there's then disconnected systems, proprietary data formats, and what this does is make integration really quite difficult. You can see here alone that when you look at data engineering, there's a vast amount of technologies, open source frameworks and tools available to you, and these differ quite drastically a lot of the time from the regular frameworks you'll see from a data science and ML perspective. And then similarly, you've got data warehousing, streaming, and data lake technologies again. And what this causes, you can see by the walls between these personas at the tops, is that because of the data architecture complexity, because of the different formats that are difficult to integrate, it's very difficult for analysts, engineers, and data scientists to really collaborate. And what this means is that from inception of idea, data use cases take a long time to ever make any progress, and they often break down due to complexity and frustration between these teams. So what does DataBricks do as a lakehouse platform? What we're basically doing is combining the best of data lakes and data warehouses. So data warehouses, as I'm sure you're all aware, are fantastic for structured data. What they allow you to do is run BI and SQL on the warehouse, provide insight to the business, but there are problems with that. It's not always real time. The data has to be structured. It struggles with unstructured data. And that's where lakes came in. So the data lake allows you to ingest a large amount of data, a large amount of varied data, and store that cheaply, but it often becomes a mess. And what DataBricks allows you to do is provide a lakehouse approach, which is a unified platform for all data analytics and AI workloads. The way we do this is through our open source project called Delta Lake, which is an open approach to bringing management and governance to lakes. It's basically a transactional layer that sits on top of your data lake and provides you with the structure and the query performance of a traditional data warehouse, but on the scale and the cost effectiveness of a data lake, hence the lake house. So just to quickly break down how DataBricks looks, as you can see, we're hosted natively on cloud only across AWS, Azure, and Google Cloud. You can ingest any type of data into the DataBricks Lakehouse platform, whether that be batch or streaming, structured all the way down to semi-structured and unstructured. You ingest that data into your open data lake layer, where you can share data through open source formats. You can ingest that and store that across any sort of lake platform. And we then have the data management and governance layer, which is obviously provided through Delta Lake. And what this allows you to do is run data engineering, SQL analytics, real-time data applications, data science, and ML, all on one simple, open, and collaborative platform. If we break that down, so why is DataBricks simple? As I just mentioned, you're eliminating silos with a simple data architecture. So using Delta, using Spark for sort of unlimited scale in terms of compute, you have all the best open source architectures and all the best open source framework within one platform. And what this means is that you don't have to worry about the management of that architecture, the configuration of that on the back end. DevOps is much simpler, and as a result, the time to value is decreased drastically. The open side of DataBricks is also a massive pull factor to why a lot of people use the platform. Our open source projects that we created and provide a lot of contribution to still, and get over 30 million plus monthly downloads. And we build our platform off this innovation, and they're some of the most successful open source projects in the world. So you're never locked in. You can chop and change which open source projects you use. And the idea of DataBricks is that we want you to be able to onboard as quickly as possible and start seeing the value as quickly as possible as well. This also means being open to other tools and technologies, whether that be BI tools for visualization, other machine learning libraries and frameworks, governance tools, working with top consulting and SI partners, or working with data providers themselves to allow you to actually ingest data into the DataBricks platform of your choice and use the user interface to give you that familiarity and that collaborative environment to use that data with. Finally, as well, it's a collaborative platform, as mentioned. The notebook environment allows you to build models, dashboards, pull in any data set from any source, and it allows any persona to do that. You don't have to be an expert in big data. You don't have to be an expert in data engineering, and you don't have to just be a SQL analyst who just wants to build dashboards. You can be any one of those things and still get the same amount of value from the DataBricks platform. And importantly, you can work with your wider teammates to do that. So that was a very quick overview of DataBricks. And what I'm going to do now is hand back over to Matt to provide you, who's going to talk about providing direct access to connected vehicle data using the Wejo platform. Thanks very much.
Thanks very much, both to Matt and virtually to Ollie. So obviously we've given you a bit of an overview around Wejo, and also really what we want to delve into now is the capability of leveraging that DataBricks environment, but also the data set that we have. So it's a true collaboration between Wejo and DataBricks. So as Matt's already mentioned, our sample preview environment has been launched now for kind of as a soft launch for the last probably 6 weeks to 2 months. But what you're ultimately getting access to here is the ability to evaluate and properly penetration test connected vehicle data in a controlled environment using pretty much some of the industry best tools. So to give you an idea of what you would get access to within the sample preview environment, we actually provide access to both our vehicle movement and our driver event data. And to put that into context in terms of scale, you would have access to 1 week of actual connected vehicle data from the 29th of March to the 4th of April from 2 of our biggest OEM partners. Now, in terms of numbers, that equates to, it's around 99 billion waypoints and about 270 million journeys. And that is right across the US, so it's not geography specific. Now, what we also have the ability to do is to preview those data sets either in silo or as a blended data set. So when I say blended data set, we have combined our vehicle movement data set from our two biggest OEMs, so that 10.7 million vehicles that you saw earlier, to give us that real depth. Now, in addition to that, which I'll come on to when I demo the environment shortly, you can actually start to get started very, very quickly from using the pre-built notebooks and the libraries and starting to get a lot more specific in terms of those locations and those queries. Now, the actual setup is very, very straightforward. What we will typically like to do as a business is to demo to any particular potential customers the environment, similar to the demo that you're going to see now. And actually what you'll have is your own dedicated instance and your own dedicated cluster. Now, why is that important? Well, it means, number one, there is no limitation on performance. And number two, any queries that you write are specific to your own environment. Now, what we also have is some very, very light touch terms and conditions, digital terms and conditions that you would fill in along with those users. And then we would actually onboard those users using Azure Active Directory. And as a very good example, we have 3 environments all ready to go already, and we can onboard in as little as 24 hours. So it really is a very kind of slick and well-oiled process in terms of giving you access. So suppose, what would I get, as a user of Wejo Sample Preview? So as I've already mentioned, this is completely free access. We typically like to limit it to 6 users, and that's not to say that we can't have more, and up to a 2-week period. Now, as I've already mentioned, the SLA, at the moment, we are onboarding customers in around 24 hours. However, typically it's around 48 hours. And you also get that dedicated environment to allow you to run those custom queries. Now, what's really, really important that we convey during this webinar is actually who is Sample Preview geared towards. So as you'll most likely see, the fact that it runs on SQL and Python and RStudio, it doesn't have the simple sliders and buttons that you would associate with some platforms. So it's very much geared towards the data analyst, the data scientist, the data architect, who is typically used to working with big data sets. So as part of that demo, that's usually the process that we'll go through, is to work with the internal data science and data analyst teams and give those people access to the environment, who are really going to be able to use it to its fullest. So with that, I will attempt to seamlessly share my screen into the DataBricks environment and actually start to give you an idea and give you a walkthrough of the environment and what you'll get access to. So hopefully that has come up now. I'm getting the nod from Matt McCann, so I'm going to take that as a yes. So first and foremost, what we always suggest any users of the DataBricks or the sample preview environment, first port of call, is to get familiar with the data schemas that we have. So we have data schemas that are available for both our vehicle movement and also our driver event data set. Now those schemas, if we have a look here, I'm not going to go through absolutely all of the attributes, but those schemas help you to get familiar with the different attributes. So as a very good example, if you're looking to understand speed in a particular area, then obviously you can use the speed attribute, but you may also want to fold in the heading of the vehicle to analyze bidirectional roads as well. So the data schemas are a very, very good place to start, just to familiarize yourself with the way that the data is structured, with the attributes, and the way to write those queries. Now, what we also have then are the driver event schema. Again, I'm not going to go through every single attribute on here, but with the driver event data, because this is a very kind of situational, contextual data set, we have things like acceleration type, some seatbelt status in there, and also some things like hard braking and rapid acceleration. But what we also have, and I'll walk you through this shortly, from some of our more recent OEMs that we've onboarded, are very, very specific events within the vehicle. So as a good example, the leveraging of wiper status or autonomous emergency braking or ABS triggering. These are all the data attributes that you wouldn't typically get from a mobile collection device or a roadside unit. So in terms of the way that the actual data is structured within the Wejo sample preview environment, with the vehicle movements data, the way we have actually set this up is we have pre-built notebooks for you so that you don't have to create queries from scratch. Now, for anybody on the session today who is a data scientist or a data analyst, you'll hopefully be familiar with the way that these queries are structured. So we're using SQL here. We've had users that have been familiar with RStudio and also with Python as well. So first things first, we've started to produce some aggregate tables for you. So as I mentioned before, a count of the number of data points and a count of the number of journeys over that 1 week period. What we've then started to do is to break that down by day, and this is across the US. So at the moment, we are very much on the helicopter view of looking at the whole of the US with that aggregate output. What we've then started to do is to create some tables. So the graphs that you have here are all fully customizable within the environment. You can create your own graphs. The one caveat and restriction that we have is that no data can leave the environment. What we've then got started to do is to break down those data points by hour. So again, at this point, it's very, very high level, and I can't imagine there are many, if any, people on today's session who would want to know, how many data points by hour for the whole of the US. But we've pre-built these queries to allow you to get a lot more specific, whether that be at the state level, the county level, or even down to the waypoint level. Now, this is where we start to create a bit more, I suppose, customizable outputs. So we have taken essentially the average speed for 3 of our biggest states, so Texas, California, and New York. And this is basically the average speed observed right across the state over a 24-hour period. I am not casting any aspersions on the way that California drive versus Texans versus New Yorkers, but this kind of gives you an idea in terms of the level of granularity that you can start to get down to. Now, the one question that we will always get asked, and undoubtedly will probably be asked on the call today, is actually how representative is the data? How reliable is it to be able to accurately model against? So what we've produced here are 2 kind of choropleth maps which detail the number of journeys and the number of data points per state. Now, if we just kind of hover over this, no surprise that we have very good representation in California, in Texas, in Florida, Michigan, New York. But what's really key with this is we have representation in every single state. And in every single state, we also have 95% representation across all roadways. But what's really key about this is, in the main, our number of journeys and the number of data points follow population very, very closely. So in that sense, you can say the data set itself is without bias. Now, the fact that probably 98% of this data set is gleaned from privately owned vehicles, we are not seeing the typical A to B behavior that you see with a lot of fleet management services. Now, what you'll also have the ability to do is to produce graphs such as this, which are heat maps. Now, again, this is just looking at the whole of the US in a heat map, and it's returning the first 100,000 queries. Now, what the good thing about leveraging the DataBricks environment is, as we start to zoom into this, because you have your own dedicated cluster and dedicated environment, these maps will re-render very, very quickly, and you're not having to wait, minutes for any query to return. So everybody will have access to our vehicle movement data set. And what you'll also then have access to is our driver event data set. So with our driver event data set, we have essentially clustered together a lot of these sensors into notebooks where the sensors kind of make sense to be grouped together. So if I have a look, firstly, for example, at this particular notebook, this looks at acceleration, hard braking, speed threshold, and I think there's also some seatbelt usage in there. So it's very much centered around a safety use case. Now, in exactly the same way as we have structured the notebooks in the vehicle movement data set, we've started to produce some really high level aggregates in terms of the number of journeys, the number of data points. And with our with our driver event data set, you can actually have access to 2 months worth of data to properly analyze and establish some controls. So if we pick out just a couple of these attributes which have been leveraged by a lot of research institutes, by a lot of civil engineering firms, on the basis that we are actually getting hard braking and rapid acceleration data from vehicles. Now, this hard braking data is very good, for example, for detecting back of queues, for understanding where there is a potential for an incident to occur in a particular area based on concentration. And what we started to then do is to actually break that down over this 2-month period. So little surprise that actually on Christmas Day, there is very little in terms of hard braking and rapid acceleration. However, in the build up to that, if you drive anything like me over the festive period, it's very irritable. There's a lot of hard braking, there's a lot of rapid acceleration occurring. So again, at this point, we are visualizing the whole of the US. However, what you can start to do is to define latitudes and longitudes and start to actually get a lot more granular with that analysis. So as a very good example here, again, you'll have the ability to produce heat maps such as this. So this is essentially visualizing the hard acceleration data for the whole month of November across the US, and it's returning, as you can see here, the first 100,000 results. So what you would probably most likely do is you would center down, generate maybe a 5-mile polygon to understand what's the general kind of behavior in this particular area, or you may want to do it at the county level. Now, what's really important about our data set is that each and every data point is augmented. So when I say it's augmented, we augment it with the state code, with the region code, and with a geohash as well. So if you wanted to produce some really high, very high level aggregates for New York City, you could quickly do that just by using the state code abbreviation. We also leverage the autonomous emergency braking events as well. So this is getting to the level of kind of level 1 automation. But this is useful in areas where there is a lot of use, there is a lot of concentration of autonomous emergency braking in a particular area. Could indicate, we've seen, clients use it to indicate that there is glare at a particular point in the day where the driver isn't quick enough to react and the vehicle has to intervene. Or it could be that actually there is a particular issue with the infrastructure of the road, and again, the vehicle is having to brake for the driver. We also leverage anti-lock braking. So again, this is producing a heat map of the number, all of the ABS triggering across the US. And then finally, the speed threshold, where the vehicle goes over 80 miles an hour and subsequently goes under. Now, I'll kind of finish the demo with just a bit of an overview around one of the notebooks, which is particularly poignant at the moment. Again, keeping with that safety use case, we start to actually look at wiper data within the vehicle. So if I just kind of move down to this area here. So I mentioned before that we actually leverage seatbelt status as well. So seatbelt latch and unlatch. Now, because that's event driven, what you can actually start to look at is, are there seatbelt latch and unlatch events happening on an interstate or on a freeway or an expressway where people are reaching 70 miles an hour and then, buckling their seatbelts up? And that could be used to promote more seatbelt usage in a particular area. And we know that across a lot of the states, there is the mandate to be able to conduct these surveys every year. Now, with the wiper data, we actually leverage when the wiper is activated and deactivated, but also the intensity of the wipers as well. So from 0 to 4. Now, in addition to that, what we also capture at the point of activation is the external temperature. Now, why is that important? Well, if you think about where, I'll use Texas as a very good example. So Texas is an area that has huge amounts of localized flooding, of microclimates. I've had it myself where I've driven through there and you pass through a curtain of rain and on either side it's completely dry. Now, what I liken this data to is essentially thousands of moving weather stations where we are seeing wiper activation, but also wiper activation with -2 degrees outside, where there is the propensity for aquaplaning. A very good example of where the wiper data has been used was a recent study conducted by one of our research partners, where they saw a huge amount of wiper activation, which didn't correlate to known rainfall. Now, what they actually found in that instance was this roadway was parallel to a huge lake, and there was actually huge amounts of cast off coming from that lake and onto the roadway and causing people to have to put their windscreen wipers on. But it's a very good example of where the data is being used as an additional layer, as an additional map layer, where typically most data sets and data collection methods fall short. So I think in terms of the demonstration itself, I think hopefully everybody's got to grips with the fact that there is a huge amount of value within these data sets, and we want people to be able to properly analyze and use the environment to its fullest, and also to give us feedback. I always encourage everybody that goes into the environment, please try and break it, use it to its maximum, use the 2 weeks to, you know, to really properly test the data out. So before I kind of finish things up, we wanted to kind of finish with, I suppose, a little bit of a couple of, I suppose, case studies. Hopefully I've switched back my screen to the presentation mode. I'm getting the nod from Matt, okay. Around testimonials that we've had from a couple of customers that have used the environment. So this is a good example of a company who, GIS and location data, very much centered around the sort of retail scenario. So, you know, a couple of example use cases here were things like point of interest trends, things like retail site location, where do I put my new location, an origin to destination in terms of, you know, what's the catchment area of that particular store. Now, the feedback that we had was, you know, the UI and the UX are actually very easy to work with. Now, hopefully you'll have seen that in the demonstration there, that yes, it doesn't have the typical sliders and buttons, but that's not what sample preview is designed for. It's designed for the data analyst and the data scientist. And I think what was key on here as well is when we start to look at the trips. So we define a trip as an ignition on and an ignition off and everything in between. We are actually capturing a lot of the short trips that aren't typically captured by travel demand surveys. So when travel demand surveys are done and people drive less than a mile, they're not usually captured as part of that. However, we were able to capture those short trips, but also the long trips that, again, most data collection methods just don't have the capability to do. And then the second is an area that we see a lot of traction and a lot of growth in is around the sort of transport and infrastructure. And this very much in keeps with your civil engineering firms, your traffic modelers. So the types of use cases we're looking at here is things like dynamic signal timing, traffic management, ITS models. So the kind of feedback that we had here was, you know, actually being able to conduct speed and origin destination using big data was a game changer. Because of the fact that we are capturing the speed every 3 seconds, you're essentially able to model out and map an entire signalized corridor where that wasn't possible before. Now, also, in addition to this, you know, the final testimony that I'll cite here is, you know, the ability to run queries at both the corridor and the intersection levels. It gives us that micro and macro view. So as I said before, by actually leveraging the latitude and the longitude within the sample preview environment, you can conduct queries on a very, very small segment of road. So there could be an area where there's particularly bottlenecks, you know, prone to a lot of congestion. You're able to look at, okay, what's happening in that area throughout over a 24-hour period, over a 1 week period, over a 1 month period. You're able to do that. So I think as a final kind of ask from me, you know, we are constantly iterating our products. We are constantly releasing products. So for those of you who've been kind enough to devote some of your time today, what we would ask is kind of vote on what's most important to you when it comes to analyzing data and dealing with big data. Is it the fact that you have to have a UI to interact with? Is it the fact that actually I have that capability, I just need the data. I just need as much data as possible for me to be able to accurately model? Or is it actually that I need the insights? So I understand what my clients need, I just need those answers quickly. So all we would ask is either for you to type UI, data, or insights, just to allow us to kind of get that insight into those of you that are attending today. With that, I will be quiet and I will take a drink and I will pass back to Matt.
Yeah, thank you very much, Matt. Great presentation as always, and you know, really great to see the tool that hopefully some of the people on this call will be able to access over the next period to really get to grips with some of our data and see how it works. So yeah, the poll that Matt just put up there, it'd be great to get your feedback on that. We have managed to leave ourselves a good 5 minutes for some questions here. So now Matt's had his drink of water, I will now question him with some of the ones that have come through. And firstly, the one that's come through is, are the queries all predefined or can they be adjusted to fit our own use cases? And then the second part of that, is it both Python and SQL or one or the other?
Two very good questions. So the the queries themselves, they are predefined. However, what you can actually do is to clone each of the notebooks that I've seen here today. So the master notebook will be locked down for the purposes of, if you're anything like me, you write a piece of code, it goes wrong, and then you've lost that initial query. So they are predefined, however, they are fully customizable. So as a really good example, the analysis that we did around New York, Texas, you could get a lot more specific with those, and you can clone those notebooks as many times as you like. In terms of the coding language, I would say most of the queries that are written are in SQL, as you've probably seen. However, we would recommend that you stick with either SQL or Python, or even, as some users have used, RStudio.
Brilliant. Thank you, Matt. And then I suppose another question, and this is one that I quite often ask with our normal data sets of how they can do it. So this is a really good one. But is it possible to do origin to destination with a pass-through filter?
Yes, is the short answer to that. So we obviously define a trip as the ignition on to ignition off. However, there are ways, and I'm not going to try and write code while I'm presenting, because that always ends badly. However, the ability to do a pass-through filter is possible through the data. So essentially, you would define the polygon and say, give me all of the journeys that passed through here, rather than all of the journeys that started or ended at this point. So pass-through filters is a very common use case that we see.
Thank you very much. And then obviously someone with a little bit of knowledge here, can we zoom into, and they've said OSM or other map segment ID level? And if so, what level?
So the data within the sample preview environment isn't snapped in any way. With our aggregate data product, so with our traffic intelligence product as an example, we do define those segments at the OSM level. So all of the data points are snapped in our traffic intelligence product. In terms of the raw data itself, so obviously sample preview is one way for you to evaluate the data. However, sometimes there is no substitute for taking that data into your own environment, using it within your own GIS tools. So the data within sample preview is not snapped, and it's not snapped to any road segments. However, that is possible with the data.
Okay, brilliant. And then I think we've probably got time for one more before we just sort of summarize and wrap up. And probably, again, quite a common one from previous is, can we import our own data into this sample preview tool, for example, POI data?
Yeah, it's a common question that we get. Now, whilst it is possible to import external data sets, it's not something that's enabled automatically, because obviously we need to be very, very conscious of what's being imported into the environment. We have had customers in the past that have imported POI data sets for the purposes of, retail is probably a very good example of this. Of, okay, I want to look at the catchment area, the number of journeys to a particular point. What we would say is, if there is a data set that you would like loaded into your instance and into your environment, then let us know, and we can enable that. All I will say is it's not enabled by default necessarily.
Okay, brilliant. So it's something we can, on occasion, sort of look into and discuss. And then final one that's just coming from the chat is, and I think we covered this, can we export a snapshot of the data for a particular polygon?
So when we say, can we export a snapshot, I think I mentioned this earlier, that the one caveat to the sample preview environment is that no data can leave the environment. Now, when we say no data can leave the environment, we mean both the ability to download the data, but also extract any visuals from there. Now, the reason for that, quite simply, is we have very, very strict data sharing agreements in place with all of our licensors. So whilst when we say snapshot, I think it's just very, very key to note that no data can leave the environment, whether that be as a snippet or whether it be the raw underlying data itself. Brilliant.
Thank you very much. I suppose all that kind of leaves us to say is thank you very much for attending. Thanks for the great questions. There's a couple more coming in, which we will get to and we will answer, and we'll document all the questions that have come through and make those available to everyone that's been here today. So thank you very much for your time. What I will say is I've put my email in the chat. You will have a number of you contacts already within Wejo. Just urge you to get in contact with us. How long would it take to set someone up in this environment if they wanted to sort of get into the sample preview tool straight away, Matt?
So for those of you that are familiar with Blue Peter, we have made ones earlier. So we do have, I think, 3 environments ready that we can onboard once we have the necessary digital agreements in place. However, in the instance that we run out of environments, then we can have those spun up in around 48 hours.
Brilliant. So first come, first served. Yeah, please get in contact with us. Like I said, my email is in the chat there. And for those of you that we've spoken to and invited here, we will be in touch over the coming days to follow up, and we'll make the recording available, and we'll also make the question and answers available. So just from myself, from Matt, from the team here at Wejo, just thank you very much for your time today. It's been a pleasure speaking to you all in this way, and hopefully we'll have some more conversations off the back of it real soon. So thank you very much.
Thank you.